Okay, so this is a little weird because I'm actually doing this like in class with you guys. So if I get stopped by one of you and get asked a question, then that's going to happen. Okay, so this is the Chapter 3 review. So we're going to start off with number 1. Mainly we're going to be doing odds here. So number 1, we have to solve these by graphing. So graphing precision is really important. So basically what we want to do is graph each of our equations, okay? So we have 2x plus 1. It's okay. We have 2x plus 1. So we know so these are both in y-intercept and slope-intercept form, which means we have mx plus b. So our slope is 2, our y-intercept is 1. Which means that then, so your first point's going to be at 1, and then your slope is 2. So when we have our slope as a whole number, that's 2 over 1. So we're going to go up 2 over 1, up 2 over 1, and that's our line right there. We then repeat that for our second one, y equals 4x minus 5. So we have negative 5 as our intercept, and now our slope is 4. That means we're going to go up 4 and over 1. And that's our line right there. Now notice that we're looking here, and it looks pretty much like right there is our, go ahead Elizabeth, our point of intersection. And that looks to be 3, 7. Notice how I did like a red line and a blue line, and then the intersection was purple? Huh? Pretty cool, right? Yeah. Okay. So we have 3, 7 there. So what I want to do now is I really just want to go ahead and check both of them. So I'm going to plug 3, 7 into both of my lines, okay? So I go 7 equals 3 times 2 plus 1. 7 equals 6 plus 1. Sure does. I go y equals 4x minus 5. So I'm going to plug in 7 for my y, 3 for my x. That gives me 7 equals 12 minus 5, and yes, it does. So that's number 1. So that's how you solve by graphing. You want to graph both lines, figure out where their intersection is. Okay, we're going to do that again with number 3. Now, number 3 is a little bit different, mainly for the fact that it's not in slope-intercept form. Okay? So up top we have 2x equals y minus 7. I'm actually just going to add a y to both sides, or a 7 to both sides. So that's going to give me y equals 2x plus 7. Okay, really simple just to add that 7 both ways. And that way I can graph it. Now here, on the next one, that's in standard form. So we have 4x. Jaden's giving me a weird look, so I'm going to erase that and write it better. Oh, is it 5?
Yeah.
Okay. What's the third problem? So if I say I'm doing odds and I eliminated a whole bunch, then that means that I'm only doing every other problem. Okay. So what we're going to do here is we're going to go y. So this is my y-intercept, okay? Actually, I'm just going to put it. So what I did here was I subtracted 2x from both sides, divided by negative 2, and I got y equals 2x minus 7. The other way I could do that, I thought about doing it because it's standard form, doing it in standard with the intercepts. But those intercepts, my y-intercept, where y is 0, or my x-intercept, where y is 0, would have been like 3 1/4. And so I just decided to do it this way. So I'm going to graph my two lines. So I have 2x plus 7 and 2x minus 7. And I go, holy crap, they both have slopes of 2. Well, what does that mean? That means they're either going to be parallel or collinear. So if we know that they have the same slope, we then look at their intercepts. Their intercepts are different, so these are two parallel lines.
Wait, question.
Yeah.
Can you just graph it for number 1, can you just graph it?
So this is parallel. So those are what the two lines would look like. So they're never going to intersect. So the answer there would be no solutions because they're parallel. Okay. Next up, what are we doing? Oh, okay. So we're looking at number 7. So number 7, what we're looking at, without graphing, determine whether each system is independent, dependent, or inconsistent. So remember, independent and dependent. So independent has one solution, okay? And that's what most lines are going to be. Dependent is infinite. So here, if their slopes are different, so the slopes aren't equal, it's independent. Dependent is the slopes are equal and their y-intercept is equal. It's the same line. Inconsistent means the slopes are equal and they're not, and they have different intercepts, so they are parallel. So what we want to do with number 7 is we want to turn each of them into slope-intercept form. So for the top one, we would subtract 2x divided by 3, and that gives us y equals negative 2/3 x plus 8/3. Do the same thing for the bottom, and lo and behold, we get negative 2/3 x plus 8/3. So, same slope, same y-intercept, so that's going to be dependent. I put inconsistent, and that's wrong. Miss Miller's class is in the middle of a rave right now. Okay, so this is actually going to be dependent. They're the same lines. And you can kind of look at that here. If you multiply that top line by 3, you're going to get the second line. Okay, so now what I want to do is I'm going to look at... Oh, this is just how I turned it in. Okay. Okay, so number 9, so we have the same slope, but different y-intercepts. So we have 3/4 x minus 3 and 3/4 x minus 4. So those are going to be parallel or inconsistent. Okay, now number 10, I had a little bit of trouble on number 10, I'm going to admit. So it took me a while to kind of set up how to do the variables. So number 10, what I did was I had Carla's 240 in nickels and dimes. So I said x is the number of nickels she has, and dimes, the number of dimes she had is y.
Can I get a drink of water?
You may. And then Darren has 550 in dimes and quarters. But here's the thing. We have this note. Darren has many dimes as Carla has nickels. So those amounts have to be the same. So if x equals nickels, then for Darren, x equals dimes. And if y equals dimes for Carla, then for Darren, y equals quarters. So then I'm going to set up my two equations right there. So 0.05x. Now I'm going to do 0.05x because that's the value of each nickel. And so I know that if I multiply the number of nickels by 0.05, and add it to the number of dimes by 0.1, then I'm going to get the total that Carla has at $2.40. With Darren, that's 0.1 times the number of dimes plus 0.25y, or 25 cents for the number of quarters. And that's going to equal $5.50. Then, because I hate decimals, I'm going to multiply both of these by 100, and that's going to give me 5x plus 10y equals 240, and 10x plus 25y equals 550. So then it's off to the races. Go to class, Alex. Hello, sir. So here we have our two equations. So we have 5x plus 10y equals 240, and 10x plus 25y equals 550. So what I'm going to do is I'm going to multiply that bottom equation by a -2. That's going to give me, so my top one is still 10x plus 25y equals 550. My bottom one is negative 10x minus 20y equals negative 480. Add those together, the 10x's cancel out. 25y minus 20y is 5y equals 70. Divide both sides by 5, and I get y equals 15. So now I know that Carla has 15 dimes and Darren has 15 quarters. I'm going to plug that in to 5x plus 10y equals 240. So I get 5x plus 150 equals 240. Subtract 150 from both sides, I get 5x equals 90, or x equals 18. So it's 14, I can't count. So it's 20. So y equals x equals 20, y equals 14. Okay? So I should be able to go back and go, okay, so if Carla has 20 nickels, then she has $1, and then she has $1.40 in dimes. Well, $1 plus $1.40 is $2.40. If Darren has 20 dimes, then he has $2. And if he has 14 quarters, then he's going to have I'm pretty sure a space shuttle just launched from the rave in, I don't know, Apollo 13? I don't know. Anyway, okay. This is Miss Smith getting back at me for how loudly I talk every single day. Do you know when she retires, I'm getting her stereo system?
I remember freshman algebra, she was always like, well, there's Mr. Bernard yelling at his class again, first hour.
It's true. I was just, oh, you had her first hour, so you got to hear us like sing and everything.
Yep.
That first hour was crazy. That was so much fun.
I know, and you'd be playing music, and then we were all like, this guy, like the music he picks.
It's awesome. Anyway, okay. So now we're solving each system of equations. So I'm not putting restrictions on you guys. You can do this by graphing. You guys can do this by substitution or elimination. Okay? So for number 12, where I have x plus y equals 5 and x minus y equals negative 3, I look at it and immediately see that I can just cancel those y's out. So I'm just going to add them together. That's giving me 2x equals 2 or x equals 1. I'm going to plug that back in. I get 1 plus y equals 5 or y equals 4. So that gives me the answer of 1, 4. Now I can always go and plug that back in and make sure by going, okay, well, if x minus y equals negative 3, that means 1 minus 4 equals negative 3, and that checks. So I'm going to do 13 now. So what I'm going to do is 13 is y equals 3x minus 1, and 2x plus y equals 14. So this looks like a prime ability for me to substitute. So I'm going to take that 3x minus 1, and I'm going to drop it right there where that y is. So that's going to give me a new equation of 2x plus 3x minus 1 equals 14. That's 5x minus 1 equals 14, 5x equals 15, or x equals 3. Plug that back in. So I have y equals 3x minus 1. So I'm going to go 3 times 3 minus 1, 9 minus 1, or 8. So y equals 8. So that gives me 3a. If I went and put it in the other one, 2 times 3 is 6. 6 plus 8 is 14. So that checks. Okay, so this next one's a little tricky. So what we're going to do is, so we know what we're looking at here is time, right? We know a kayaker can paddle 12 miles in 2 hours moving with the river current. Paddling at the same pace, the trip back takes the current against the current takes 4 hours. Assume that the river current is constant, find the kayaker's speed in still water. So we know that So 2x plus y, and it's actually going to be 2y. I'll change that in a second. So 2x plus, here, I'll just show you. So 2x, that's 2 times moving with the current. Hold on just a second.
I just wanted to do
Okay, so 2x, so that is, so x is, so look over here on the left, x is paddle speed, and y is river speed. So if I know that I go two hours at my paddle speed plus 2 hours of river speed, I'm going to travel 12 miles. Okay? Now, to get back, it's going to take 4 hours of paddle speed minus 2 hours of river speed. And that's also going to equal 12. So those are my two equations there. Okay? Now, right away, I see that those y's are going to cancel out if I add these two equations together. So that's what I'm going to do. I'm going to go 6x equals 24, or x equals 4. So my paddle speed is now 4 miles per hour. Then I can just plug that 4 back into either one, and I should get the same thing. So if I plug into the top one, I'm going to get 2 times 4 plus 2y equals 12. That gives me 8 plus 2y equals 12. 2y equals 4, or y equals 2. Okay, so now technically, because I only have to find the kayaker's speed in still water, I don't technically need to find that y is 2 miles per hour. But I wanted to, that way I can check my answer. I can plug it back into the other equation. So here, if I'm going 4 times 4 is 16, 16 minus 4 is 12, so that checks. So I know that the kayaker in still water is paddling at 4 miles per hour. Okay, so now we're doing graphing inequalities, which is everybody's favorite. So this is number 20. Y is greater than or equal to x minus 3, and y is less than or equal to 3x plus 7. So we're looking for that kind of feasible region where both are true. So we're just going to graph this. We're going to graph them. They're both solid lines. So that's what x minus 3 looks like. Our intercept is -3. Our slope is 1. And because y is greater than that, if we were to shade the entire thing, we'd shave up. Shave up, shade up. I'm not shaving at all. So for the next one, we have y is less than or equal to 3x plus 7. Start at 7, and our slope is 3. And we would shade it down. So the area where they're both right is that purple area right there. Thank you, sir. He's not here today. He's not here today. Just kind of part of the problem. Thank you. Okay, so next I wanted to do one of the ones with, so I'm doing negative x minus 4 and the absolute value of x plus 2. And it's negative absolute value of x plus 2. So that first one we're just going to graph as normal, right? -4, slope of -1, that's our line. The second one, so we have an absolute value. Now remember, the absolute value is going to give me a basic graph like a V, right? That negative is going to flip it upside down, And the plus 2 inside the absolute value bars moves it 2 to the left. Now notice we don't have any number out here in the A slot, so it's not going to compress it, it's not going to stretch it, so we're still going to have a slope of 1 and -1 on both of the sides. So when we graph it, that's what it looks like. Okay, it's upside down V with a vertex at -2, 0. Now, we have it as x is less than, so it's going to be that area right there. Only those points are going to make both equations true. Now, if you want to be like super careful, like I can pick 0, 0. Now notice, 0, 0 is going to make the red equation true, not the blue equation. Okay, plug in 0, 0. Is 0 greater than -4? Yes, it is. But I plug in 0, 0 here, and I get 0 is less than -2. False. So that checks. For both of them to be true, I'd want to pick a point like right there, which is -3, 0. So -3 is greater than -4, true. -3 is less than negative absolute value of -3 plus 2, absolute value of -1, or -1. So I have -3 is less than -1. That's true as well. So that area right there, that purple area, that's where both of these are going to be true. Oh, and I need to dot the line because it is less than and not less than or equal to. Okay. Again, if any of these ever don't make sense to you, go back, rewatch them. If they still don't make sense, drop me an email or ask me in class. Okay, so fish equals X, chicken equals Y. So we have 4X plus 3Y is greater than or equal to 11 and less than or equal to 15. Now we got this because we know she's spending at least $11 and no more than 15. So whenever we see that kind of at least, no more than, we can break it down into two equations of greater than the no at least and less than the no more. So what we want to do is we want to graph these just really quickly. So that's my, right there, that's my system of inequalities. Graph the system to show the possible amounts the way I look at by. For 4x plus 3y is greater than 11, I'm going to put in my intercepts at 3, 3, and 2, 5. And that's the minimum I'll spend. The maximum I'm going to spend is 15, which puts my y-intercept up at 5, 0, and my x-intercept at 15 divided by 4, or 3.5. And that's the most. So that purple area, again, that's where I can spend. Now notice here, both of those lines have the same slope, so they are parallel. So don't get confused by that. Alrighty. Linear programming, everybody's favorite. So I'm going to do that first one. X is less than or equal to 4, greater than or equal to 3, greater than or equal to 0, and less than or greater than or equal to 0. So notice these bottom two. I'm going to create that just by doing this in the first quadrant. Take the pass, please. So my objective function is 2x minus, or plus y, rather. So I'm going to graph x equals 4 and y equals 3. So when I do that, that's what I get. That's my feasible region right there, that little box down at the bottom. And I'm going to label my vertices. 0, 0, 0, 3, 4, 0, or 4, 3 rather, and 4, 0. So now what I'm going to do is I'm going to plug each of those into the equation and get my p. Now notice here, p is 3, 11, 8, and 0. I got the 3 by plugging in the 0, 3. That's 2 times 0, 0, plus 3, 3. The 11 is 2 times 4, 8, plus 3, 11. And the 8 is 2 times 4, 8, plus 0, 8. So the max of that equation will occur at the vertex 4, 3. Okay, next up. Okay, so this is the word problem. Okay, a lunch stand makes 75 cents profit in each chef salad and $1.20 in profit on each Caesar salad. On a typical weekday, sells between 40 and 60 chef salads and between 35 and 50 Caesar salads. It never has sold more than 100 salads. How many of each type should be prepared to maximize profit? So we're going to let X equal the number of Caesar salads we're making. We're going to let Y equal the number of chef salads we're making. And we are then going to go from there. So X has to be greater than 0, Y has to be greater than 0. So we're in our first quadrant. So we know that okay, so that's the equation y equals 40, and we would go up from there. That's the line y is less than or equal to 60, and we go down from there. So that is the number of chef salads we're going to make. Y is less than or equal to 60, and y is greater than or equal to 40. So that's X is less than or equal to 50 right there. And that's actually an arrow going in because it's the maximum number of Caesar salads we're going to do. And that's the minimum number of Caesar salads we're going to do. So, okay. Are you just listening to me?
Yeah.
Okay. So what we did here was we took, so I'm just re-explaining this, a student just came by. So we graphed this. I want to make sure I go out the right amounts. And then I graphed my 4 lines. My 4 lines again, y is less than or equal to 40, or greater than or equal to 40, less than or equal to 60. That's the number of chef salads. Caesar salads in between 35 and 50. So that gives me 4 lines. Okay? Does that make sense? Okay. So then we have our final line, which is x plus y is less than or equal to 100.
So do you just get those from this?
From there, right.
Okay.
Okay, so let's break this down. Okay, so I'm going to hop back. Give me a second. Let me pull up. Give me just a second.
So I'm trying to follow you and you're going so fast.
Okay, I'll slow down a little bit.
Okay.
Open. There we go. Okay. So, if I were, I'm going to write on this paper and then I'm going to go back.
Cool.
Okay? So, a lunch stand makes profit, so on each chef salad and $1.20 on each Caesar salad. So, right away, that should key us in that our variables are going to be the number of chef salads we make and the number of Caesar salads we make.
Alright.
Okay, so we're going to go x equals,
This is 30.
I think I went x equals Caesar salads,
Yeah.
and y equals chef salad. Okay? Does that make sense?
Yeah.
So then what I'm going to do is they just gave me my objective function, my profit function. My profit function, the amount of profit I make is on each Caesar salad, I'm going to make $1.20. And on each chef salad, I'm going to make 75 cents. So that's my profit. That's my objective function right there. Now, on a typical weekday, it sells between 40 and 60 chef salads. So that means y has to be greater than or equal to 40, and it has to be less than or equal to 60. Also sells between 35 and 50 Caesar salads. So that means X is greater than or equal to 35, and X is less than or equal to 60. Or 50, sorry.
Yeah.
Okay, so those four, does those make sense?
Yeah.
That's the limitation on the number of salads I'm making. Now I also know that we never sell more than 100. So I never sell more than 100, so I'm never going to make more than 100, right?
So X.
Okay, so does that make sense?
Yeah.
Okay. So if I go back to here, okay. So that's where we were before, right? So these lines, the red lines, are the limitations on my chef salad. And these blue lines are on my Caesar salad.
Are there going to be a lot of word problems on the test?
There'll be like one or two. Okay. Now my final one is x plus y is less than or equal to 100. Now I know that my two intercepts are 100, so I can just tag the hundreds and connect them. And that gives me that area right there as my feasible region. Only the numbers in there will make all of my equations true.
Yeah.
Okay? So I know from the vertex theory of linear programming, or the vertex principle of linear programming, rather, that the maximum and minimum of my function, my profit function, 120x plus 75y, is going to be at one of my, I have 4 vertices, or 5 vertices here. So I'm going to label those 35, 40, 35, 60. Oops. This right here is 40, 60. And then I have 50, 50 and 50, 40. So if I list all those out, keep hitting the wrong button. Okay, so these right here, those are my 1, 2, 3, 4. Oh, I forgot one. I forgot 50, 40. No, it's right there. Okay, so those right there are my 5 vertices. I know the maximum is going to happen when I plug one of those into my equation, 1.2x plus 0.75y. So what I do now is I run those two numbers. Each of those are ordered pairs through the equation. For the first one, I get p equals 72. For the second one, I get p equals 81. For 40-60, I get p equals 93. For 50-50, I get p equals 97. And for 50-40, I get p equals 90. Which means that my max profit of $97.50 under these circumstances will be accomplished when I make a equal number of chef salads and Caesar salads. Okay, so this penultimate one, we're looking at number 38. So actually we're looking up at the system of equations. So I'm going to look at 32 first. So what we're going to do is we already have x equals 2y. So we're going to plug that in right there. So right now, and then we're going to drop it down. So we have 2y plus y plus z equals, or plus 2y plus 1. Because what we did there is once we have z equals 2y plus 1, we take it there and drop it right there. Okay, so that gives us 2y, x, plus y, plus 2y plus 1, z, equals 6. So that's going to give us 5y plus 1 equals 6, or y equals 1. Plug that back in for x equals 2y, and again x equals 2 times 1 or 2. z equals x plus 1, or 2 plus 1, or 3. So my ordered triplet is 2, 1, 3. Add all those together, 3, 4, 5, 6. That checks, so we're good to go. A little bit trickier on something like 37. 37, what I'm going to do is I'm going to get rid of my z's. So multiply the top one by negative 2. It's going to give me negative 4x plus 3y, or plus 6y, minus 2z equals a positive 16. Then my second equation is x plus 9y plus 2z equals negative 3. Add those together. You get negative 3x plus 3y equals 13. So now what I'm going to do is I'm going to multiply that top equation by a negative 5. And that's going to be negative 10x minus 15y minus 5z equals negative 40, or positive 40 rather, because I'm multiplying it by a negative 5. You guys, go work. Head off, please. 5x. Oh dear, sorry. Okay, give me just a second. So now we have negative 5x minus 6y plus 5z equals negative 11, or positive 11, negative 15x minus 21y equals 51. So I have my two equations, negative 3x plus 3y equals 13, and negative 15x minus 21y equals 51. Multiply the top one by a negative 5, I get 15x minus 15y equals negative 65. People, get to work on bell work. That gives me negative 36y equals negative 14, or y equals 7 over 18. And so I went back and I looked at this, and I'm like, hey, that's actually right. So you don't have to do 37. Okay? 37 is a phenomenal pain in the butt. I looked at the answers. That's how unsure I was about this. And so in the answer, when they're doing it, one of these, I forget which one, I think that was like a negative z right there or something. So it completely changes the entire setup of the problem and what you multiply by it. And you get a really nice triplet like negative 2, 1, 2 or something like that. Not here. Okay, see, did it again, did it twice, got the same answer. You do not have to do this. So number 38. This is a word problem. It's a 3 variable. So what we're going to do is we're going to go, all 3 of them work together and transfer 4,150 gallons per day. The first and the third, A and C, or A and B together, do 3,200, and A and C together do 2,900. So what we're going to do is I'm going to solve the second and third one for y and z. So just subtracted x from both sides. That was on these two. And that allows me to then substitute in and gives me the equation x. Now instead of y, I'm going to write 3,200 minus x. And instead of z, I'm going to write 2,900 minus x. And that's going to give me 4,150. So I get negative x, because I have x minus x, 0, minus x, negative x, plus 6,100 equals 4,150. Subtract 6,100 from both sides, and I get negative x equals negative 1950, or x equals 1950. So now what I'm going to do is I'm going to start building it back in. Okay? So I know that y equals 3200 minus x. So I go 3200 minus 1950, or 1250. And then z is going to be 2900 minus 1950, or 950. And then I can go back, double check my work, plug those in, and check and make sure they're right, and they are, and they're done. If you have any questions on this, go ahead, drop me an email or ask me in class.